All right, so today we are deriving the kinematics formulas.
Do it.
Actually, for the first 3 weeks, me not shaving my head really won't do that. Okay. You probably, if I told you this on Friday, you probably wouldn't have been able to sleep last night with excitement. So thankfully I didn't, and hopefully you were all well rested. So we're going to come up with 3 different equations, and I'm going to call them, oddly enough, equation 1, equation 2, and equation 3. As we go through them, the derivation of them becomes increasingly complex. So the first one is a sort of a warm-up. Okay? Do you recall your old friend A equals delta V over delta T?
Yes.
Hopefully you do. Now, you might also remember that delta V could be written as Vf minus Vi because it's simply the change in velocity, right? So I'm going to take this portion of that and I'm going to substitute it in there, which gives me A equals Vf minus Vi all over. Now I'm just going to sort of let the delta T sort of become T. Sort of going to make a typo on purpose. Okay? And I could just, I'll add on the side here, I'm going to say that delta T is equal to Tf minus Ti. But almost virtually in every instance, what is the initial time? 0. So in other words, delta T is equal to Tf, or just the time. Right? I mean, as long as you sort of know that it really is delta T, it's the change in time, really. But like I said, 99% of the time, it's just equal to the time because the initial one is 0. And then I'm going to rearrange this. I'm going to write AT is equal to Vf minus Vi. And then the way that we usually write it is final velocity is equal to initial velocity plus acceleration multiplied by time. And that, my friends, is kinematics equation number 1, which really isn't a whole lot different than what you were working with back in grade 10. Or grade 11, sorry. Oh, grade 10 probably as well. 10, 11. The reason that we sort of give you this one in grade 11 is we want to reinforce that idea of change in things, right? Change in time, change in velocity. So I fire that one at you all the time, try to reinforce that. Now that you're wise, we can use Vf equals Vi plus At. Jake has a question.
I was going to ask if there's a plus or a
Vf equals Vi plus At. And if you stop and you think about it, right, the final velocity is whatever the initial velocity is, right? And then you add on whatever change there is given by the acceleration multiplied by the time, right? And the acceleration could be negative, which would make the final velocity less, right? Could time ever be negative? No. This is known as kinematics equation number 1. Pretty straightforward, right? We're all good? No one was too stretched in their algebra skills there, I'm hoping? Yeah, pretty straightforward. You're good. Well, I hope you're ready now because equation number 2 is a bit more. Oh, need a black page. Equation number 2. Displacement is the area under the VT graph. Displacement is an area under the VT graph, such as this one. Right? So we're talking about this area under here, right? Now, what shape is this shape here that I'm going to draw in red? What geometric shape is that? Dallas is right. Wow, that's
Really
fast. Holy moly, that is a trapezoid. Do you even see it? Or are you just throwing out crazy geometric letters and names that I know? If you turn it like this, generally people think of the trapezoid as the thing that the elephants stand on at the circus, right? That's generally what people think of. But if you take this, and you go like, whoa, and you go like that, and instead of having this line like that, it's just like that, it's the same as that, right? It's a trapezoid. Well, a trapezoid generally is, like I said, is generally thought of as triangle on one side, triangle on the other, rectangle in the middle, right? But the one side triangle doesn't necessarily have to be. If you look up the geometric definition of a trapezoid, I think it's one pair of, nor is it at least one pair of unparalleled lines, right? So there could be one pair of sides that are parallel. Anyways, what's the formula now, Dallas, now that you've thrown this out? What's the formula for area of a trapezoid? It's based on that. You could do that, Joy, but there's sort of a simpler sort of, and we could derive that, but I'll just tell you. Anybody know? It's you'll know when I show it to you. It's side 1 plus side 2 divided by 2 times the height. Does that? Pardon me? Oh, yeah, good question. Does that sound vaguely familiar at all? Maybe? Maybe not? Okay. So in a regular trapezoid, this would be the height, and this would be side 1, and this would be side 2. So, as Dallas said, a rectangle is length times height, right? If you take side 1 and side 2 and add them together and divide by 2, what in essence are you doing? Finding the side 1. What's something plus something divided by 2? You end up with the average of the two. So what we're really doing is we're finding the average of this side and this side, right? So basically what it does, it sort of scoots out S1 a little bit and scrunches in S2 a little bit, and then you end up with a rectangle. Okay? None of that is particularly needed for what we're going to be doing here. Okay, so get rid of this. There's our area. And Joey asked a real good question. What is the side 1 and side 2? Well, I showed it to you like this, but what is it over here? So side 1 is going to be, and what I'm going to do is I just want to show you it doesn't necessarily have to start at 0. So I'm going to just fix this a little bit here. I want to find the area of this red area. Okay, so side 1 is actually that one there, and side 2 is that one there, and the height is that one there, right? But what do those mean on a VT graph? So I'm taking the concept of a trapezoid, and I'm applying it to a VT graph. So side 1, this would be the initial velocity right there. It could be. It depends on your velocity time graph, right? It could start at 0, right? But because I'm dealing with formulas, I can't assign it to be 0. I have to just assign it to a generic variable, VI. I didn't convince you, did I? How about I'll go through this, and then I'll throw it in with 0, and then maybe you'll see the connection. Like it has to work for instances where the VI is not 0, right?
But if you triangle, or sorry, if the VI was 0.
It would be a triangle, yeah, absolutely, right? But we don't always know that the VI is going to be 0. Okay, so I have to. When I derive formulas, I have to use variables. I can't use numbers. So my VI is this value here. I guess it's actually that one. Wait, I've got it locked there. And then this thing here is going to be VI. So my side 1 is equal to my VI, and my side 2 is equal to my VI. Okay, and my height is this distance here. Side 1 is equal to, oops, not side I. Side 1 is equal to VI. Side 2 is equal to VF. And my height is equal to my difference in times. Now here's where I'm going to have to use that delta T. And the area, which is the displacement, is equal to side 1 plus side 2 So that's VI plus VF divided by 2 multiplied by my height, which is delta T. Okay? Now that's not exactly in sort of a usable format, so we're going to sort of do some manipulations here now. I'm going to write D for displacement. I'm going to pull out the divide by 2. Would you agree that dividing by 2 is the same thing as multiplying by a half?
Yeah.
So I'm going to take 1/2 times VI plus VF, and I'm going to multiply by delta T. Now I'm going to take this equation from way back here, VF equals VI plus AT. I'm going to take VI plus AT, and I'm going to plug that in for VF, because I got too many variables here. 1/2 of VI plus, and I'll put it in red for you. What's VF equal to? VI plus AT, and now I'm multiplying by delta T. Have I lost anyone?
So you have more variables.
I added one. Well, I didn't like those ones. To be honest, I don't know the reason why we do this, but you'll see a nice condensed formula that's very useful when we get to the end.
Why can't we just go now?
Oh, it's easy. Trust me. Wait till you get to example number 3, or equation number 2. I'm almost done here. VI is the original black one, right? And then this VF has been replaced with VI plus AT.
Why do you not like VF?
Let me finish up with the final formula and then I'll show you. Well, sometimes it's just easier to explain it once you see it at the end. I'm not avoiding it. Not on purpose. Well, I am, but there's a reason. Okay, so now let's combine what's in the middle there. So I've got 1/2 of VI plus VI is 2 VI. What just happened? 2 VI plus AT times delta T. Now we already agreed that this T should really be a delta T, right? Can I multiply everything all together now? I've got 1/2 times this bracket times delta T. Can we do it all multiply in one big step? Can I go 1/2 times 2 VI times delta T?
Probably not.
Yeah, of course you can. Sorry. No. 1/2 times 2 is going to be 1. So I've got VI times delta T. So I'm going to write. Oh no! I'm going to take this times this times this, and then I'm going to take this times this times this. I'm going to put it in 2. You'll see it. This is it. We're done. Yeah, 1/2 times 2 VI is VI times delta T is VI delta T. And now I go 1/2 times A times T times delta T is going to be 1/2 A delta T squared. And quite often I just write that as D equals VIT plus 1/2 AT squared. And that, my friends, is kinematics equation number 2.
Oh.
The delta T doesn't matter as long as your initial is 0, right? And as long as, if there's 2 times, then you have to know to subtract them, right? The T is really time elapsed. So what is this formula useful for? You can find how far a car or object or ball or whatever it is, how far it goes given the initial velocity, the time, and the acceleration. Okay? Now, Brandy asks, how come we got rid of the VF? Quite often, in a problem, you don't know the final velocity. They're not going to give it to you, right? They're not going to ask you how far. In fact, if they did, then you could just take the initial and the final, find the average, and multiply by the time you have the distance, right? So quite often, they don't give it to you, nor do you know what it is. Okay, for example, if I drop a ball off the Leaning Tower of Pisa, right? I can find the time it takes to fall by using a stopwatch or whatever you might have had when your Galileo time. Know the acceleration is minus 9.8, and the initial velocity is 0. In fact, almost always when you're dropping objects, the initial velocity is 0, and this whole part just what? Drops right out, disappears. But you don't often know the final velocity.
Okay.
See, I told you it would make sense when you got
It
it.
would have made sense if you just told me right away.
Maybe.
But it's
But I think you see it better now, right? So this is a real useful formula. In grade 11, you would have needed 2 or 3 steps, 2 or 3 formulas to sort of be able to do this. What we've done is be able to sort of combine a bunch and make a much more useful thing.
Can we just skip all that half and just write?
Oh yeah, oh yeah. No, don't misunderstand me. Every time you do a problem, you don't have to do all this mumbo jumbo. I'm now giving you have your license now. You passed the test. You have the license to use this. Yeah. No, sorry, I should have told you that at the start. Yeah. People always ask me that. No, you don't have to show all this work. Okay. How about fractions? Who loves working with fractions in algebra? Come on, you're lying. No one does. I don't even like it. I have to follow my notes here just because I messed this up. Equation number 3. Take equation 1, and I want you to isolate t. When I say isolate, what does that mean? Like solve for t, right? Write it as t equals. So the formula was VF equals VI plus AT. I want you to write it for t. What does t equal to? Okay, there's Joey's suggestion, VF minus VI over A. Is he right? I think he is, right? Let me check. Yep. Okay, and we're going to... Come on. We're going to substitute into equation 2. Yeah. Right away you know this is gonna suck. D equals VIT plus 1/2 AT squared. And I'm going to use black and blue here. D equals VI. T is equal to VF minus VI all over A plus 1/2 of A times VF minus VI all over A squared. Oh, that one should be in blue.
Worse.
Are you having fun yet?
Yes.
Yeah! Woo! Could I come up with a more complicated thing? No. Brandy's saying, why are we doing this?
well, no, why? You just said we don't ever know, like, rarely know what VF is. Why do we have VF in there now?
Okay, so what we're doing here is we're coming up with a formula that's going to solve for VF given VI and A and D. When we don't know the time, we can come up with the final velocity. It'll all be beautiful at the end, trust me. It's a big mess, it's like painting your house. It's a big mess for a while and then it looks great when you're done. But, as I said earlier, your algebra skills are going to be challenged today, as are mine. You know what, in 2 years, even a year, you'll be taking calculus at university and you'll look back at this and you'll go, that was child's play compared to what I'm doing now. I'm not scaring you, I'm just giving you the
No,
facts.
that's scary.
Did you
You're
guys
gonna have
teach at
nightmares.
university?
I never did. I don't know what they do anymore.
Because you're so advanced.
No, they wouldn't let us. They wouldn't let us. Okay. How do you want to deal with this? What should we do first?
None of the above.
Here's what I'm going to do. I'm going to multiply VI into here. Do I need to keep it as blue and black to keep them separate, or can I make it all one color now?
Make all black.
Okay. We should be able to do that now. So, VI times this is going to be VI VF minus VI squared all over A. And I'll pause there for a second to make sure that you see that. I'm going to combine 1/2 and A to just A over 2. Is that okay? Now, how do you square this ugly mess over here on the right?
Like right.
Well, let's start with the easy part, right? Let's start with the bottom. A squared. That was easy. Now, do you remember how to square something like this, a binomial? Something like VF minus VI squared. I remember how I used to teach it back in the good old days, but I'm not sure how math people teach it anymore. It's going to be VF minus VI times VF minus VI. Right?
Oh, that makes sense.
Yes. Do you remember the rule? I don't know how they teach that rule now. It was like grade 10, it was like automatic when I was like something like x minus y squared. If I gave you x minus y all squared, can you do that in your head? What would it be? I'm thinking it should be automatic for you. No? Isn't it x squared minus 2xy plus y squared? Okay, so now apply that to this. So it's going to be, you have to take the VF times each one of these, right? So VF times VF is going to be VF squared. Then you have to take the VF times the minus VI, and you get a minus VI VF. And looking ahead, you have to multiply minus VI times VF to give you another minus VI VF. So in other words, I've got 2 VI VFs. And then VI times VI is VI squared. See, it's not that bad. Child's play, Brandy. Educated child's play. Okay, now, I've got a big mess over here plus a big mess over here. Is there any canceling? Can you see some canceling in your future? You know there's going to be some, right? You can just tell. You're not quite sure where, but you can tell. Is there any immediate canceling that we can do? And I will direct your attention to the a over 2 and the a squared, while I rewrite this stuff over here. Okay, I've got an a on the top and I've got an a squared on the bottom. Can I cancel those? Well, that one can go away, and then what goes away here? Just a single one, right? So I'm left with an a on the bottom, and I'm left with this over here, this 2. So I'm left with a 2 on the bottom and an a. So the whole thing is over 2a. And now I have rewrite VF squared minus 2VI VF plus VI squared. Well, that'd be kind of pointless, wouldn't it? Okay, what do you remember about adding fractions from probably about grade 7 or 8? Common denominator. What does that mean?
Oh, no.
Oh, yeah. What does common denominator mean? What is a? What does where is the denominator? Yeah. We're gold, Jerry. Okay, so common denominator means that the thing on the bottom has to be common, the same. This is a, this is 2a. So I gotta, this is the part I hate, is having to rewrite everything. But I do it because I do it in support with you. Whoops. Okay, so in other words, I gotta make this whole thing over 2a, right? And how do I do that? By multiplying the top by 2 as well. So it's gonna be 2 VI VF minus 2 VI squared. And now that it's all over, or now that it's common denominator, I can write the whole thing all over 2a, right? And here's where it gets good. Well, this is the part where it starts getting smaller. Formula derivation is all about making it big and wide and then canceling and making it nice and small and compact. So how do you add? You just take everything on top and you add everything over here, right? I've got 2 VI VF minus 2 VI VF. See you later. Now I've got minus 2 VI squared plus VI squared. Minus VI squared, right? Why did I write it kind of in the middle like that? Well, what's left? I just combine those two. All I got left is VF squared. Should I put plus VF squared here, or should I put plus VF squared out front? Put it in front. We traditionally don't like our things starting with negatives, right? So we're going to put it out front. So look at how.
Oh, that's it? Oh.
Almost. I mean, you can use it in that format, but the point of this was to come up with a formula for final velocity action. So I'm going to rewrite it in that. I'm going to take this 2a. It's going to come up here. I'm going to have 2ad is equal to vf squared minus vi squared. And then I want vf squared by itself, so the vi squared goes to the other side. And here it is. Vf squared equals vi squared plus 2ad. Put a red box around it, wrap it up, put it under the Christmas tree. Done. That's a lot of work for a nice, small, compact, useful formula, right? Like I said, formula derivation is about making big, crazy messes and then cleaning it all up to make something useful again. So here I can find, I can determine final velocity, I can determine displacement if I don't have the time.
So, how big a part of this?
Oh, you're going to use this. Oh, how big a part of the class is formula derivation? You're done. I mean, you're going to see other ones, right? It's part of the experience.
Yeah.
Right? It's like going to Disney, and it's part of the experience. Will I test you on this? No. All you have to do is, did I sit through it? Did I nod and get it? Yeah, okay. I kind of get what he's talking about.
We just need to know the formula.
You just need to know the formula.
I'm sure that you could call it a salmonella experience.
Well, fair enough. Fair enough. I'll pause there for a second. I would suggest